Goal today is we're going to be looking at reflecting figures across the axes on a coordinate grid. There are definitely more things that you can reflect it across. Today we're focusing only on the axes. All right, so the figure below or above is reflected over the x-axis. Let's write the original points and the new points. All right, so we've got this figure, it's this triangle. You can go ahead and connect the dots because I know you love to connect dots. And so we have this triangular figure, and we want to reflect it over the x-axis. So what we know about reflections is that it takes a point, and whatever line you are reflecting it across, you are going to be exactly the same distance from that line, except now you're moving it to the other side. So we think about where we see our kneecaps in the water is exactly the same distance away. So this A is now going to be 1 unit away from the x-axis. So notice this question says the x-axis. That's really important. We're going to be 1 unit away on the other side. So when I'm looking at my B, I see that I need to be 1, 2, 3, 4, 5, 6 units away. But now I'm going to be on the other side. So I'm going to go 1, 2, 3, 4, 5, 6 units away. And this is where my B prime is going to be. One thing that I notice here is that when I'm reflecting across the x-axis, that it isn't actually changing how I'm moving left and right. So when you see your reflection in the water, it's not like your reflection is moved from right in front of you. It's still right in front of you. All right? Yes, sir.
So you're saying that how many times up to all the way to the x-axis you have to copy it?
Yeah, so when we're talking about reflections, yeah, you're looking for something to be the exact same distance away from your line of reflection. All right? So in this case, we're talking about now we're 2 units away from my line of reflection for C, which means I need to be 2 units away on the other side. Now, the great thing about reflections about the axes is that there's a nice, easy kind of rule that we can use. Now, I don't suggest trying to memorize the rule in its most basic form, because the rule for reflecting something over the x-axis is different than the rule for reflecting something over the y-axis, but they're very much the same. So if you try and just memorize the two rules, you'll probably get them confused. In fact, I know I do. So when I look at this, I would create a problem like this for myself, which you'll actually do in a second, to kind of memorize the rules. So let's actually look and see what happens to our coordinates. So somebody give me the original coordinates for A. Kali.
2, -1.
2, -1. Original coordinates for B. Brandon.
3,
-6. And C. 1. 5, -2. And now our new coordinates are prime coordinates. Somebody give me the coordinates for A prime. Giselle? 2, 2, 1. Somebody give me the coordinates for B prime. Dahlia? And the coordinates for C prime. Jaquan? 5, 2. Now, let's look at what happened to our coordinates. We should be able to see a kind of pattern in the change here from one set of coordinates to the other. Do me a favor, take 15 seconds, turn to your partner and tell them what you see as the kind of idea about what happened here with our coordinates. So we find that we look at it this way, and Jaquan is saying, well, the next problem is exactly the same. What is different about this next problem? Lola. Yep, so this now says the y-axis, and this is where we have to be super careful. And this is a problem that I know a lot of you guys run into a lot, is not reading a problem before you start doing a problem. So it's a very small detail, the difference between an X and a Y, but it makes a very big difference. So now, this is like our pond's edge is over here. And so we're reflecting it now across the Y-axis. So I'm going to do the same thing. This is 2 units away from my line of reflection, so I'm going to move it 2 units to the other side. This is now my A prime. This is 1, 2, 3, 4, 5 units away from my line of reflection, so it needs to be 1, 2, 3, 4, 5 units away on the other side. That's my C prime. And my B prime should be 1, 2, 3 units away on the other side. So I have my new figure that clearly looks reflected across that axis. One way that you can think about something being reflected is if you took that line of reflection and you kind of folded your paper right there, everything would kind of like match up and touch each other, okay? So that's another way you can think about reflections and the way they should look. Yes, sir?
Now, since the last problem, the Y is negative, now the X is negative.
So Jaquan is starting to look at this and he's starting to recognize, well, when I flipped it over the Y-axis, I see that I'm not moving it up and down, I'm only changing my X values, okay? And so let's go ahead and write down our points to see if we can find a common rule here. So I'm going to give me the points for the coordinates for A. Edgar? 2, -1 was our original coordinate for A. Original coordinates for B. Original coordinates for B. Brandon? Yes.
3 negative 6.
3, -6. Original coordinates for C. Jasmine? Yep. 5, and then this is -2. Okay. And now, what are my coordinates for A prime? Nina? -2, -1. Coordinates for B prime? Brandon? -3, -6. And coordinates for C prime? Dahlia? -5, -2. Turn and tell your partner, what changes happen to our coordinates? Yeah, so the X changed signs. Y stayed the same. So what's the difference between reflecting across the y-axis and reflecting across the x-axis? What's the difference? This is where we contrast two things. Ayla. Yeah, so, and this is exactly why I think that it's a bad idea to try and remember the rules. Ayla's absolutely right here, but she's thinking in a kind of a more general way, and this is very good. This is going to bode well for her when she's trying to use the rule. So she says that when you're flipping across the y, and this is literally, if you see me do a problem like this, and I haven't been looking at the rule for it all day, you will literally see me go, the problem says reflect something across the x-axis. You will literally see me go, okay, x-axis, literally, my hands will go up just like this. I'll go x-axis, all right, I'm flipping up, or I'm flipping down. So all I'm changing is my y, okay? quite literally, that is what I will do. So it says y-axis, I'm like, okay, y-axis, that means I'm flipping something across. The only change is to my x. Otherwise, you're trying to memorize, okay, if it's x, then I flip the y. If it's y, then I flip the x. And then you start to get all of that mixed up and confused, when instead, if you can visualize it, you're good to go. All right? Now, beyond visualization, you may also want to go ahead and literally create yourself a problem to remind yourself of the rule. So what I want you to do is you're actually going to use that concept right now as a tool to help you figure out these problems in the future. Create your own problem that you can really quickly recognize how it should be flipped across the x-axis. Graph the triangle, then graph its new reflected triangle, and answer the question below. So you're going to be doing this whole panel right here. You're creating your own problem, and you're reflecting it across the x-axis. And then you're giving me the coordinates. All right? On your own. Work. That looks like this. I can see that is clearly correctly reflected, and then I can see that the points are correct because they seem to follow the rule. Now, the great thing about this is I actually watched Isabel. I was copying her work as she was working, and not in this class. And the perfect thing happened. I literally watched it happen. She went through, she graphed her 3 points, she graphed the reflections of her 3 points, she wrote down her 3 original points, and it took her a couple seconds to go back and find the points for this first one. And then the second 2 points, she didn't even look back at her graph, because by the time that she had done the first point, she was like, oh yeah, this is the rule. I don't need to look back. I just need to look over here and tell me what the rule is. And that's the whole point of this. The whole point is that you should be able to create this rule on your own rather than trying to memorize it, all right? I want you to do the same thing with a triangle flipped over the y-axis.